All the operators we have talked about so far are binary operators, meaning they have two operands. For example, if you add first and second together, the addition operator is called a binary operator because here we have two operands. But we also have a bunch of operators that take a single operand. We refer to them as unary operators. Examples are the increment and decrement operators. So let's see how we can implement the increment operator. Now, this is a special operator because we can apply it in the postfix or the prefix form. Do you remember the difference? Let me refresh your memory. So I'm going to delete all this code and declare two integers, x and y. Now, if we apply the increment operator in the prefix form, first, the value of x is going to be incremented, so x will be 11, and then the result will be returned and stored in y. So in this case, both x and y will be 11. However, if we apply this in the postfix form, first, a copy of x will be returned and stored in y, so y will be 10, and then x will be incremented by 1. That is the difference. So now let's see how we can implement this operator in our length class. So back over here, we're going to add two more functions, operator plus plus without any parameters, and this is for applying this operator in the prefix form. So the return type has to be length as a reference because we'll be working with an existing object. We also need another overload that takes an integer parameter. The name doesn't matter. We just need an integer parameter. This is a way to tell the compiler that this implementation is for applying this operator in the postfix form. Now, earlier I told you that when we apply this as a postfix, in this case, first a copy of x will be returned and stored in y. So because we need to return a copy, the return type has to be length, not length as a reference, because we will not be modifying an existing object, okay? So now let's generate the definitions for these functions. Okay, so here's our prefix form. Again, I want to put the ampersand right here. So in the prefix form, first we need to increment the value of the current object, and then we need to return the current object. So just like before, dereference this. Now, let's generate the definition for the other overload. Okay, in the postfix form, first we need to take a copy of the current object. So we create a length object, we call it copy, and we set it to dereferenced this. Now, this line doesn't get compiled because earlier we deleted the copy constructor. So to make this work, we have to allow the compiler to generate the copy constructor. So we need to delete this line from here. And that also means we should allow the compiler to generate the default assignment operator as well. Okay, now back to this function. So we take a copy of this object. Next, we need to increment the value attribute. So we can either increment it directly, but the problem with this approach is that if tomorrow the logic for incrementing a length changes, then we have to apply that change in two places. So it would be better to delegate to the other operator plus plus. So we have a single place for incrementing a length object. So here we can call this function just like a regular function, okay? And finally, over here, we return our copy. As simple as that. Now let's test our implementation. So back to our main file, I'm going to delete all this code and create two length objects, first and second. Now, if we apply the increment operator in the postfix form, I expect the second length to be 10 because first a copy of this object is returned. So the second length is going to be 10, and then this object is incremented. To verify that, let's print these objects. And one more time, the second. Take a look. So first is 11, second is 10. Beautiful. However, if we apply this in the prefix form, first this object is incremented, and then the result is returned and stored in the second object. So take a look. In this case, both of them are 11. Fantastic. Now, as your exercise, I want you to implement the increment operator in the point class. Again, the steps for the solution are repetitive, so to save time, I'm not going to show the solution.